So we want to define electric potential. So first notice that force is equal to Q times the electric field. So this we have noticed before. And you take this Q as test charge. So test charge is always positive and it is of very small quantity. So it is positive and infinitesimally small. So work done by the field. So we are talking about work done by the electric field. In moving this test charge Q in the field E from point A to B, so there is a field and there are 2 points given in the field A to B. So work done by the field in moving a test charge from point A to B, this is given as, we know this formula, force dot product with displacement, and you integrate from A to B. Now force is given as Q times E vector, then again dot product with dx vector, Q comes out. So the work done is given as Q times integral of E vector dot product with dx vector going from A to B. So suppose electric field is given like this. So you know electric field is always going from positive side to the negative side. So this is emanating from, say, some positive charge. You have a point A, you have point B. So you could go either this way or this way, or you could go, I'm going to draw in another color, this way or some other way. So the work done will always remain the same. The work done depends upon the displacement and the electric field. So displacement from A to B, which will be given by this vector always, that is AB vector, and the electric field. So work done as before depends upon the force and the displacement. Here the force is defined as test charge times the electric field. Now we know that change in potential energy of the system is given as minus work done. Now notice that minus work done is equal to work done by the external force in moving the test charge from A to B. So work done externally. So W here is work done by the field. Wx is work done by the external force or some external agent who will move the test charge from A to B. Now this comes, the change in negative sign comes from the Newton's third law. Yeah, because the force applied by the external agent is opposite to the force applied by the electric field. So by the Newton's third law, there is an action and a reaction. Forces are opposite in sign and therefore the work done is opposite in sign. So the change in potential energy would be minus work done. So potential energy at B minus potential energy at A. So UB minus UA is equal to minus work done, that is minus Q times integral of A to B of E vector dot product with dx vector, where E vector is the electric field and dx vector is the displacement. So now you define electric potential as the potential energy divided by the test charge. So this V is the electric potential. The units of V are volt, but we will talk about that later. So now you can say that you divide both sides by Q. So you get UB by Q will give you VB, U subscript A by Q will give you VA. So this is equal to integral of A to B dot product of the field vector with the displacement vector. So you can write VB minus VA as delta V vector, that is change in potential is given as minus integral from A to B E vector dot dx vector. So this is the formula for potential difference in a uniform electric field. So this is potential difference between 2 points A and B in a uniform electric field. So again, this will depend upon the displacement from A to B and the electric field. Now say if electric field is constant, it does not depend upon the displacement. So then delta V vector would be, you can take E vector outside, and you get dot product of E vector and X vector. So where X vector is a displacement, you can write it as minus E times X cos theta. So where theta is the angle between electric field and the displacement. So displacement vector is the X vector. So let us draw theta in the figure we have already drawn. So you know AB is the displacement and you have angle theta between the electric field and the displacement. So let us discuss some cases when this electric field is constant. So say when theta is pi by 2. So when theta is pi by 2 or 90 degrees, then you know that cos theta is 0. So that would mean that delta V is 0. If theta is 0, then cos theta is 1. In that case, delta V would be minus E times X. When theta is 180 degrees or theta is equal to pi, then cos theta is minus 1. And in that case, delta V is just Ex. Theta is now pi, then delta V is just E times X. So since cos of pi or cos of 180 degrees is minus 1. So again we draw the figure. You have displacement from A to B and you are given electric field as E. So electric field is going like this. So always notice that electric field lines are always coming out of positive charge and going towards negative charge. If any, if there is no negative charge, they are just emanating out of positive charge. And we are saying if electric field is constant and angle theta is given, this is how the cases will look like.